Hello everyone, my name is Somish, my partner name is Roshan, and we have made our project as FM modulator and FM demodulator, and also we have made AM modulator, AM demodulator. Basically analog modulation we are performing. So I will walk through this circuit design, explaining each block, and then show live oscilloscope results for the carrier frequency at a broad range of 1 Hz till 1 megahertz. So I have performed FM modulator using the IC-XR2206, which is basically an function generator. So it is a 14-pin IC. I will explain those pins in the IC which are needed to perform FM modulation and demodulation. Rest of the pins I will explain into the my report. So this IC-XR2206 at the pin 5-6 there is one capacitance. So the timing capacitance sets the nominal frequency ranges. So this if I on this button, it will select this capacitance. So changing the switches, you can change the capacitance values. Also at the pin number 7, I have one potentiometer which will vary the current going into the pin number 7, which shift the carrier frequency. So if I add my voltage signal empty here, that will lead to change in the current going inside the pin number 7. So my instantaneous frequency will change as FC plus KF empty. If my empty is 0, then it will set a fixed frequency, that is carrier frequency. Now if I want to operate at different frequencies, so I need to change the capacitance values and the resistance through this potentiometer. So we have added dip switches to select different CT values. For example, 1 picofarad for 100 kilohertz till 1 megahertz range. The 50 kilo ohm potentiometer at the pin number 7 adjusts the DC bias choosing the center frequency FC. Now message injection. Our message empty, which I fed through a coupling capacitor at the pin number 7. If the as empty swings, it modulates the control current. Thus the instantaneous frequency will change, thus performing the FM modulation. So the output of the FM modulator will come out from the pin number 2. Also, the shape of the waveform of the carrier wave can be set up by the resistor value connecting at the pin number 13 and 14. Now from the pin number 2, we will get our FM modulated signal. Now if I want to demodulate that signal, I need to perform first differentiation, and then I need to perform the envelope detector, because when we differentiate our FM signal, which is nothing but cos of 2 pi FCT plus kf times of integral mt, if I differentiate this signal, then the phase term will come out in the envelope part, which is nothing but 2 pi fc plus mt. So my message came out in the envelope part of the differentiated FM signal. Now I will show you. I will explain you the working of how the demodulator is working. So I have implemented the limiter discriminator. So in this we have first differentiator. I built the differentiator from low pass, basically a band pass filter. So implements j omega, our carrier band, to convert the frequency deviation into amplitude variations. So we can operate the band pass filter into a differentiator at the rising edge of the transfer function. Now after this, I have implemented one buffer. Also the gain of the bandpass filter is very less, so to amplify the signal, I have used one inverting amplifier. Now the output of the differentiated amplified signal is going to the envelope detector. So I have built one basic envelope detector following by a diode and the parallel combination of one capacitor and one resistor. That is, instead of using resistor, I am using potentiometer so that I can adjust the ripples coming in the envelope detector. The value at the of this capacitance and this resistance, a diode plus this RC network that tracks the envelope of the differentiated output. This gives us a voltage proportional to the instantaneous frequency. The RC time constant is chosen so that the discharging time matches our highest message frequency. Now after the envelope detection, I have implemented one low pass filter to filter out the ripples coming into the envelope when I detected the envelope. So low pass filter will attenuate the higher frequencies, so it will smoothen our message signal. So at the output of this low pass filter, we can retrieve our message signal which was giving at the input. So the explanation of this circuit is over. Now I will show you the simulations outputs. Simulation outputs. So I have set the carrier frequency at 124 kilohertz. I can change this carrier frequency with the help of this resistor value. So you can see that if I am changing the potentiometer, the frequency of the carrier signal is getting changed. So it goes up to till 900 kilohertz, and the lower will be at 123 kilohertz. If you want to change this carrier frequency ranges, you need to change the capacitance value which I initially told through these switches. So I have not given the input yet. So the output of the this IC is coming out to be a fixed sinusoidal wave at a frequency of 124 kilohertz. Now I am turning on the wave gen. Basically I am giving the input. So the output at so I am giving message signal of 7 kilohertz and a amplitude of 3 volts peak to peak. So I will show you the FM modulated wave. So you can see that the frequency is changing with respect to the message signal. When the amplitude of the message signal is getting higher, the frequency is getting lower. The frequency of the modulated wave is getting higher when the amplitude is getting lower. This is because the expression this basically it is this because the input is inverted. So if you give the non-inverting input, then when the message amplitude will decrease, then the frequency will also decrease. So as you can see clearly, my carrier my wave, so the frequency of the modulated signal is varying with respect to input. So the our FM modulated wave is this. Now I will show you the output of this. When I differentiate this FM wave, then the message signal should come into the envelope of the differentiated wave. As we can see clearly, the amplitude of the differentiated wave is varying with the message signal. Now if I want to retrieve my signal back, I need to extract this empty from the envelope. Now I will show you the envelope of the like the retrieved envelope. as we can see clearly, the envelope is retrieved at the output of the envelope detector. Now if I want to remove these ripples, I will pass this wave through a low pass filter so that it will smoothen. As you can see clearly, my the ripples are totally gone, and I have retrieved my message input, which was initially sent at 7 kilohertz. That is this. Now if I vary the message signal frequency, you can see here the output retrieved signal. So you can see clearly I am giving the input at 8 kilohertz and I am retrieving the frequency of 8 kilohertz. You can see clearly.